So we want to solve 4 to the x minus 8 times 2 to the x minus 9 equals 0. So the way we're going to do this is by making a substitution. So we're going to let u equal 2 to the x. So then u squared will be 2 to the x squared, which is the same thing as replacing the 2 and the x. And the idea is that when you multiply, x times 2 is the same thing as 2 times x, right? This is the commutative property. So this is 4 to the x. So 4 to the x is just u squared, 2 to the x is u, and so I just need to solve for u right now. So I can factor this into u minus 9, u plus 1. So u will be 9 and negative 1. U we said is 2 to the x. So we're going to set 2 to the x equal to 9 and negative 1. Notice 2 to the x is never negative because it's an exponential. So it's always going to be greater than or equal to 0. Sorry, strictly greater than 0. So there's no solution for this one. Now for 2 to the x equals 9, you want to take the log of both sides. So the exponent will come out in front. You have x times ln of 2 equals ln of 9. So x is ln of 9 over ln 2, which we wanted 3 significant figures. So the decimal is 3.169925. So if we round the third decimal, that's going to be 3.17. Now for part B, suppose that there was a misprint and it should have been plus 8 times 2 to the x. So if we look over here, when we get down to this step, it should just be plus 8u instead. So the steps, above here should be all the same. Except this step changes, it becomes plus 8u. And so I can factor this as u plus 9, u minus 1. And so u is negative 9 and 1. Okay, so u we said is 2 to the x. So it's 2 to the x equals negative 9 and 2 to the x equals 1. 2 to the x is never negative, so this doesn't make any sense. There's no solution for that. But if we look at 2 to the x equals 1, we can take the natural log of both sides. Exponent comes out in front. We have x times ln of 2 equals ln of 1. Well, ln of 1 is just 0. So x is 0. So that's the answer for part B.